Hello everyone, welcome to In 5 Minutes. In this video we are going to see integration over a given volume using cylindrical polar coordinates. In spherical polar coordinates we have some limits and we have some type of substitution. So here also we will have some substitution and how to find the limits of the other variables. So in cylindrical polar coordinates we have cylinder. So what is cylinder? Cylinder is nothing but it is a type of cake. You all know what is cake. So let's say this is our birthday cake. Okay, so this cake is the type of cylinder. So we have to find the polar coordinates of this cylinder. So let's keep this center of the cylinder in three axes. What are the three axes? Three axes are X, Y and Z. Okay, so now this cylinder will have 8 parts. How 8 parts? Take this cylinder. If we cut the cake in perpendicular directions, okay, and if we keep our axis in the middle, so above we will have 4 pieces and below also we will have 4 pieces of the cake. In total we have 8 pieces of the cake. That means when we place the coordinate axis at the center of the cylinder, we will get 8 parts of the cylinder. Let's consider this one piece. So it will be something like this. So this is one part of the cake. Okay, so now we have to find the cylindrical polar coordinates. Let's consider a point P here. So this is our point P. So the distance of point P from Z axis is nothing but R. When we project this point P on the XY plane, we get this distance also equal to R. Let's say this angle is phi. Then this will be our Y coordinate and this will be our X coordinate. Okay, so X will be nothing but R cos phi. If you consider this thing, this is nothing but our right angle triangle. So we have right angle triangle. Here we have 90 degree, here we have phi, here we have X, here we have Y, and this is our R. Then X will be R cos phi and Y will be R sin phi. So this is the substitution. Then what will be Z? Because in Cartesian coordinate we have X, Y and Z. So what will be Z? Z will be nothing but this distance, which is nothing but Z. So in cylindrical polar coordinates, we substitute X equal to R cos phi, we substitute Y equal to R sin phi, and we keep Z equal to Z. That is, we keep Z as it is. So these are the basic substitution. Then we also substitute dx, dy, dz. In this case, dx, dy, dz will be R dr d phi dz. Okay. In spherical coordinate, we used to have r square sine theta. So instead of r square, we will have r dr d phi dz. So what are the limits of this x, y and z? If you know the limits of r, this r is nothing but radius of the cylinder. So cylinder radius can be anything starting from 0 till infinity. Okay, we can have as big cylinder as we want. Okay, so these are the limits of r. What will be the limits of phi? If you see, the limits of phi will be starting from this point and it will make one complete circle, because the cylinder is circle when we see from the top. When we see from the top in the xy plane, we will get one circle. So we are starting from this point and we are ending from at this point. That is, our phi will vary from 0 to 2 pi. So the limits of phi will be from 0 to 2 pi. And what will be the limits of z? We can have any height of cylinder. Z represents the height of cylinder. Okay, so we can have as high cylinder as we want. Okay, so the limits of z will be from minus infinity to plus infinity. So these are the basic limits of r, phi and z. We can have this r, phi and z in any of this limit. Okay, this will be more clear when we see the problem on this.